All right. Hey, everyone. Welcome to the training series for Neo4j Bloom. Like Alex mentioned a couple of minutes ago, Bloom is our visualization tool, which is to be used on top of Neo4j Graph database. And the value here is that you are able to visualize all the relationships and nodes you have in your database ad hoc. So it's all point and click. You don't need to know the graph, the Cypher query language. You don't need to know any coding mechanisms to get started with Bloom, to play around with Bloom. So in that way, it's very flexible. Um, and not only that, we have a lot of advanced features in Bloom as well, which is for power users who want to really use the security aspect of it, or who want to go deeper into sharing and collaboration modes and all that. And we'll of course take a look at that, take a look at all of that today. So like I said, it's very intuitive to use anyway. But the best part of this training, and I really liked it, is that it's completely hands-on. So of course I have some slides, but those are really for walking all of us through the know-hows of the tool, and um, just some rules, or just some data regarding what is to be done, or some queries, or some instructions and all that. Nothing really very there is no overwhelming amount of information in the slides, so it's very hands-on. And feel free to follow with me if you want to. There are some exercises that you might want to follow along, or just enjoy the training and you can follow along later. It's completely recorded. The slide deck will be shared with you as well. And we'll be importing a very cool data set. Now, we'll be doing this with Cypher, which is Neo4j's query language. But don't worry, we are not getting into the weeds of Cypher. We are not getting into every individual query. We'll just be using those queries that we already have. You will just copy paste them in the query box, and go ahead and just run them to get the data loaded. So a quick overview of Bloom. Where Bloom comes into picture is at the intermediate or end stage of the graph databases. So why I say that is because when you load your data and you want to start exploring what's in your data, right? Hey, show me what's in my data. That's the first time, or that's the usual first interaction with Bloom, when you start visualizing what's there in your database. Of course, it's very powerful to look at the data in an aggregated, or if you run a very big query, or if you run some very complex query and you get tabular results. Of course, it's very powerful. But to look at the graph, like the structure itself is connected, right? And to look at that on a canvas is pretty powerful, and that adds a lot of value. Uh, the Another thing I really like about Bloom, and this is what most of our users really love about Bloom, is the near natural language search part. So like I mentioned, you don't need to know a lot of Cypher, or really to get started, you don't need to know any Cypher in Bloom. It knows what you are looking for. It suggests you the schema. It suggests you what can be queried. It knows what's in the database. So Bloom suggests you, hey, okay, so you have typed this. You can maybe also add this and discover a pattern. And of course, we'll look at that. You can edit the graph or create some new nodes in Bloom. You cannot delete relationships and nodes, but that's just because of the security reasons. You don't want analysts or people who are just playing around with dataset to delete anything, right? You can inspect your nodes in a very nice card view. We'll look at all that. This is just sort of building it up. There is expansions, there is shortest path, which is really cool again. And all of this is happening on a computer powered by some chip, right? So I don't want to get into details of it, but it's basically backed up with a rendering engine in your computer. So the better I guess the better GPU your computer has, the quicker Bloom will respond, and the better Bloom will render. Again, it's not about how fast the query runs, because that's all the database, but how fast the visualization pops up, and how seamless the visualization looks like. And there is a terminology called perspective, which we will go into. It's sort of a view of the data. If anyone is coming from relational databases world, they will know what a view is. It's like locking down what can be seen, locking down what can be accessed in that particular view of the data. So you can really add properties, or you can choose to not show any sensitive material, any sensitive properties. Like, okay, so let's say you have a perspective for end users or for analysts, and you don't want your analysts to see social security numbers for your customers, or you don't want them to see birth dates for customers. Then you can use this perspective to really eliminate or to lock down that part of it. Now, how to get started with Bloom? Where is Bloom available? The first and the one which I'm going to use today is Neo4j Aura. Aura is our database as a service, so a fully managed service running on AWS and GCP, and Azure is coming shortly. I think sometime early next year. But Aura is a database as a service. It has three tiers. The first one is the free one. There is a professional version which you can just put in your credit card, get started, sort of scale better. And then there is an enterprise one for those mission critical workloads. Today we'll be using Aura free. We don't need to input anything, just log in and get started. The second option is Neo4j Sandbox, which is it's sort of an environment that we provision for you, and you can choose to have a blank sandbox, which is suggested for today because we'll be loading the dataset. Or there are a lot of pre-canned datasets, and really good ones for fraud detection, for recommendations, graph data science. The Paradise papers that recently came out, Neo4j was a big part of that investigation. And by that, I mean that Neo4j helped ICIJ investigate all those financial linkages and connections. The third one is Neo4j Desktop. This sort of creates a hook. So it's a downloadable software, and it gives you access to the entire Neo4j Graph platform on your laptop. You can use Bloom, you can use the Graph Data Science library. There is a procedure library called APOC, which is awesome procedures on Cypher. You can download that, and GraphQL ecosystem, and a whole lot of stuff. And the fourth one is as a plugin for Neo4j Server. Now, this one is really mostly for the enterprise users, where they have set up Neo4j on a virtual machine on AWS, Google Cloud, somewhere, and there is a jar file which you can add into the Neo4j database folders and make Bloom accessible that way. But that's really an advanced mechanism. The first three are are important for today, and among that, the first one is what I am going to be leading with. But of course, I will show how to spin up a sandbox, how to start the Aura, how to start this Aura instance, and so on. Now, just a brief introduction to Aura and Neo4j Browser. So these two components are one of the two components is Neo4j Aura, which is, like I mentioned, it's our database as a service. Now, I forgot to scratch this one. We recommend using Neo4j Sandbox. You can also use Neo4j Aura. I am going to use Aura just because for the preference. There is no one is better than the other. The only difference I can let's see. Yeah, the only difference I can think of, and which is really a critical difference, is that Neo4j sandboxes are ephemeral. So they are going to be shut down in 3 days, or if you extend, maximum 10 days. So 10 days tops, the instance goes away. Neo4j Aura, if you create a database in Neo4j Aura, then it is going to stay with you as long as you want. So that's the only difference I can think of. Um, and of course, you want your database to stick with you, right? You don't want it. You can play with it later as well. Now, Neo4j Browser is a tool that we'll be using to load our data. It's sort of like an IDE for Cypher. So you can write your code there. You can inspect your schema there, um, and do some really cool stuff in there. So let's get started. Now let me quickly go to Neo4j Sandbox first, since the slides say that that's the preferred way, but we can do that. It's fine. Now, if you go to sandbox.neo4j.com, and let me quickly paste this in the chat. Um, if you go to sandbox.neo4j.com and log in using your single sign-on provider, I think Google is the easiest for most of the people. Going to Neo4j Sandbox is going to take you to this landing page where there's a new project button right here, and there is some help and guides and everything. And there's a little card here that says start free on Aura, and there's also one that says start free on Aura DB. And I will also show how to get started with that. But for Sandbox, let's click on new project. Now, if you remember, I mentioned there are a lot of pre-canned pre-canned data sets here. So we have movies, which is the very basic one. But then if you want to start getting more advanced, there is this graph data science data set. There is a network and IT management, recommendations, fraud detection, contact tracing for COVID, especially. And it can get really fun. But since we are loading this data ourselves, let's go ahead with blank sandbox. And I hit create. It's going to show what's going on. It's behind the scenes. It is going to set up a small virtual machine, and you can see it's up and running already. Now, I mentioned here that it expires in 3 days. You have the option to extend it to 10 days total, but after 10 days, it's going to go away. Now we are here and we are done with setting up a blank sandbox already. There is connection details, username and password, which is provisioned by us. There's some information on how to connect through programming language drivers, and you can request a backup of the database in case you want to keep it that way with yourself. Now let's move to Aura and see how to get started with that. So the link for that is going to be console.neo4j.io. Let me again copy paste here. Yep. So console.neo4j.io, and then again log in with your single sign-on provider. Google is the easiest for most of them, most of us. And then it brings you to this console. Now this is the console for Neo4j Aura Free, or Neo4j Aura DB really, which is the naming for our database as a service. There are some tabs here. One for databases, so every running database you have will be shown here. We don't have any, so it's blank. There's an import section where it will guide you on how to import dataset if you have it running somewhere else. There's a connect section, which is similar to the sandbox one that we saw. It has a guide on how to use Aura with different programming language drivers, Java and Python and etc. There's a feedback section, which will take you to a feedback page. Feel free to give feedback or ask for help if any. There's a documentation link and support link here as well. Let's create a database. So hit on create a database. Now, there are two tiers right here. The first one is AuraDB free, which we are using today. And the other one is AuraDB professional. So the difference is that AuraDB free lets you create one database, and there are some limitations on how many nodes and relationships you can load because it's a small instance, right? Uh, it has our APOC extension enabled, and there is an auto pause feature. If you are not using the database for 3 days straight, our system detects it and it pauses the database for you. So the data is still there, the database is still there, but it's paused just to save on costs. And you don't need to have a credit card to start. Uh, as we'll see here, we can start pretty fast without any information. Then there is Aura DB Professional, which is also a self-serve offering, but you can create unlimited number of databases, and you can provision the machine according to your requirements. So let's say you are playing with a very large data set on your own for some development purposes, right? You can go all the way to 64 gigabyte of memory, which is huge, 128 gigabyte storage, and it also suggests you how much it is going to cost. There are some cool features like on-demand scaling, so you can really increase or decrease the instance size without any downtime. It's a blue-green handoff, and available in a lot of most of the global regions wherever AWS or wherever Google Cloud is present. There are daily backups with a 7-day retention policy, so your data is backed up, and you can back up your data on demand as well. But this is a paid tier where you have to input your credit card. The third one, which is not mentioned here, is the enterprise one, which sort of you have to contact us and we talk to you and we do about your use case and everything. That's for mission critical workloads. But let's dive into AuraDB free, which we are going to use. So database name, we are going to look at a very cool Winter Olympics dataset. So let's just go ahead and say Winter Olympics. Uh, Google Cloud, currently AuraDB free is only available on Google Cloud Platform, uh, coming on AWS sometime next year. Three regions, Belgium, Singapore, and Iowa. I am in the US, so the closest to me is Iowa, so I'll go ahead and select Iowa. Now, if you want to have a walkthrough guide for Neo4j, you can always start with movies dataset. But for this purpose of this exercise, we are going to get started with a blank one. So I will click on load or create your own data in a blank database, and I will hit create. Now, be very, very, very careful with this. So this auto generates a password, which we are going to 100% need to log into our database. So what I like to do is just take this, take this copy to clipboard, just maybe start something like a rapid table note and just paste here, right? So this password stays with you, and I will show you how to change the password. We will do that, but just for the first time login, we need this password. So be sure to save this password somewhere. Now, once I have saved it, uh, I'm going to use this checkbox and hit continue. Now it's provisioning the database here. Now we have seen how to provision database in Sandbox, which also has a password, but it's always here, so you don't lose it. But for Aura, make sure that you save the first password somewhere to log in for the first time. Takes a couple of minutes to provision since the whole infrastructure is being provisioned. Um, and let's go ahead and actually see what the data is going to look like. It's very fun. Um, it's a Winter Olympics data set from 1896 to 2016. So hundreds of years, 200 years, I guess. No, not 200 years, but yeah, more than 100 years of data set coming from Kaggle. So the actual data set is very big. It has Winter Olympics and Summer Olympics, but for the purpose of this exercise, we'll be only looking at the Winter Olympics one. Doing a quick time check. Perfect. All the queries, data, everything is in a GitHub repo. We will share that with you after the course. Um, but we'll also share it with you through chat if anyone wants to follow along. Um, I have no idea why this database is offline. So, yikes. Just going to refresh to make sure nothing is wrong here. Okay. Yeah, that just tells us that, hey, I'm a real person, right? Um, things can go wrong. They always do in live demos and sessions. So I am going to destroy. Now, if your database is running, don't destroy. I don't know what happened here. So I am again going to go with the same process, checked AuraDB free, naming the database Winter Olympics, selecting a region, selecting the blank database, and hitting create. Now this is a different password, so making sure I save this one and continue. Okay, so going back here. Yeah, so a really cool data set, and I will bring up this data model again in when we load the data. But the idea is to have a team which is representing a country, right? And then the team competes in some event here, and the team uh, participates in those games, right? So there are the games. Winter Olympics takes place different places every year. So those locations, the name of those respective Olympics, and then the city that they are held in, and then every team has a bunch of athletes, right? So athletes are a part of that team, and then the team wins medals if they manage to win a medal. Let's see what's going on with Aura here. If this um, if this does not work again, we will just continue with Sandbox for now. But for those of you who are using Neo4j desktop, you can go ahead and create a new database. Um, for the purpose of this session, I won't show how to do that, but um, there are some really good quick tutorials on how to get started with that as well. So Neo4j desktop, you can just hit download and click learn more to get started there. Let's see what's happening here. Still setting it up. So yeah, we just went through this, right? Yep. Go to neo4j.com, sandbox.neo4j.com, or this link will also route you to the same place. Sign in and click blank sandbox, or go to the Aura free instance, create database name. Now you don't have to do this part, share database size, it's off. Just click create database and make, again, as this says, make a copy of the generated password. We are going to need it. Let's refresh. I swear I did this a couple of times in the last 2 days and it worked fine. That's fine. Things always go wrong in a live demo. So I'm a solutions architect here, and a part of my job is to talk to enterprise customers, talk through their use cases, and design a proof of concept, or take their data and do something with their data, help them meet their service level agreements and so on. So basically talk to customers and give them demos of our product using their data and so on. And things always go wrong in a live demo. That's our way of saying that, hey, this is not a recorded session. We are here. Perfect, running. I am very happy to see this. Now it's running, up and running. If you click on the Winter Olympics part, we will go in this console. Now, either one can import a dump file, which is basically a database dump. If you have a local database stored, you can import out the dump and store the dump, upload the dump here. It's pretty cool feature. If not, you can load data through the language drivers. If you have some advanced data pipeline mechanism to fuel in data, you can do that. But remember, for Aura free, there is a limitation on nodes and relationships. So be mindful of that. Snapshots are just backups of your data. And then there's a way to clone and delete. So clone is going to let you make a duplicate of your database, and delete will destroy the database, just like we did a couple of minutes ago. Nice. Now it's very obvious here, and you got that right, that we are going to click on open with, and here you see Neo4j Browser and Neo4j Bloom. Now, don't get too excited yet. We are not going to go to Bloom directly. Let's first go to Neo4j Browser, since we have to load our data in, right? Click on Neo4j Browser. It's going to bring you to this beautiful console. Let me actually okay, cool. So at this left side, you see a pop-up, right? Navigating Neo4j Browser. What to do? What is Neo4j Browser? Um, you can walk through this guide later. We don't need this right now. So if you just click this little TV icon, it will go away. Now remember, I said save the password, guys. Save the password. We will need this password right here. Copy this and paste it here. Click connect. Let's make sure. Perfect. So we have connected to our Aura instance. Now this is a little golden nugget from this session. We are actually going to change the password so we don't have to use this annoying huge password that we have saved. So for that, we have to do :server and then change dash password. I hope that's right. Yeah, it's right. And then put the existing the huge password and give some password you like, really. Or you can ask our system to auto generate, but it will again give a big one. And I'm going to click on change password. So now when I log into my Aura, I don't have to input this pre-canned huge password. You can see their password was successfully changed. Just to show you that it really did that, I'm going to do a disconnect. Oops, sorry for that. Server disconnect. That means I'm really logging out, and then I am going to use the new smaller password that I set to access my database. As I do that, I am connected. Perfect. Let's also look at how to do this same thing in Sandbox. We have this blank sandbox. You guessed it, right? Click on open, not yet with Bloom, open with browser. And the good thing about Sandbox is that the password is stored, or it's here, so you don't have to change. Just simply copy to clipboard, firing up Neo4j Browser, give it 30 seconds to load up. Take a sip of coffee while that happens. All right. I think there was also some trying to, yeah, there was an option to also open this with, oh yeah, you can, if you have a Sandbox running, you can add this project to your Neo4j desktop if you have it, sort of handing it off to your local system. Pretty cool feature. See here, it's connected. We don't need to change the password because it's already there. Now Neo4j supports multiple databases in the enterprise version. So select your database here. Just to make it a uniform experience, I'm going to go to settings here and do a normal mode instead of the dark mode, making sure it's the same here. Perfect. All right, so we are connected. Let's go back to the slides and let's actually import some data. Now, loading the data is pretty easy using Neo4j Browser, which is this thing that looks like an IDE. You can type in here Cypher queries here, and we will see in a moment what else we can do here. Just for the informative sake of it, I like to click on this database cake icon. it's really going to show you all the information when once we load the data. And I like to keep this open before I load the data so I can see what all is getting loaded and how. Just making sure. And guys, these are just some tips that I use in my daily life. It just makes the life a little bit easier. uh, we have to copy all the queries from this part here. Let's click. um, like I said, don't worry, you don't have to you don't have to write any cipher query. We have written that for you. Let me copy this and paste it here. um, Sorry if it looks super weird. I'm trying to see if oh yeah, I completely forgot about questions. So if you have any questions, please put them in the chat. Alex can take some, or the one of the things I noticed in the past sessions when I was doing some webinars was that uh, participants actually answer each other's questions, and that's wonderful. Collaboration in this virtual online environment is super awesome. I just loved how people were answering each other's questions, and I'm sure we'll see some of that today as well. So let's go to this query section. I want to kind of go into what's happening here, but very briefly. So the first part here, actually, scratch that. Let's copy everything. Control C, Command C, and paste it into this query box. Now I can make this query box bigger to this double-ended full screen section. And I'm not going into query of what's happening really here, but in the first part, we are creating some constraints and indexes, which we are going to use in Bloom later. And indexes are really useful when you are creating relationships, because you find the node based on that index, and then you can create a relationship. And then we are loading a bunch of CSV files, a bunch of big CSV files from their hosted locations, and we are using Cypher to load the data. Now we are not going into the details of what the query actually looks like and how. There are separate training sessions that I will share links for uh, towards the end that you can use to take courses on Cypher, data modeling, and so on. But without further ado, let's run this query. Now you will see check marks as things start loading. Now everything from this step is going to take a tiny bit of time because it's a 40 megabyte CSV file. But you can see here 18,000 nodes quickly added. Really a testament to how fast Neo4j loads data. This is nothing. Enterprise customers do billions of nodes in just a couple of hours, millions of nodes per minute, and so on. It's very powerful. But you can see nodes getting loaded here, relationships getting loaded here, and that's why I said that I like this view, because you can see what's getting loaded. You can see our data model that we discussed. Once this is done, and remember, this is a small instance. We are working on a small instance. So if you want a blazing fast speed for such a small data, you can run it on your 32 GB MacBook or what have you, and load this in 2 seconds as well. But our data is loaded now. Go back to Neo4j Aura. I want to refresh this just to show you how I don't know why this is not. Okay, that's fine. Like I said, live demo, right? So the data loading part in Neo4j Aura is complete. Let's take the same set of queries and run it in the Sandbox as well, just to keep it on the same ground. Now I'm going to let this run. We can go back to Aura. We can go back to the browser. Now, the first thing I like to do whenever I play with any new data, any new data, may it be customers' data, may it be a toy, synthetic data set, anything, I like to inspect the schema. Now, Neo4j is schema flexible, schema optional, but whenever there is data, there is some sort of structure to that, right? There is no strict enforcement in Neo4j, which is again a value that you will add if you use Neo4j, is that there is no enforced schema. It's very optional, it's flexible, but called db.schema.visualization right here, and hit run. So for running this query, you can either do this blue play icon, or you can do command enter or control enter on Windows. So that's going to run the query. Awesome. Look at how pretty that thing is. If you see here, there's an overview of what is on this canvas. It's sort of like a mini visualization. We can do visualization in Neo4j Browser, but on a very small scale, maybe couple of hundred nodes, not more than that. But you can see here the data model that we have. The one that we saw in our slides was the exact same one. So we have a team. Um, let's extend this a bit. Cool. We have a team represented. We have a team that represents a country, which is a red one. The team competes in some events. Bunch of athletes are going to be a part of team, and we will look at the cardinality aspect of it. The team participates in various games, various Olympic games, and those games are held in different cities. So this is what the structure of our, or the schema of our data looks like, right? And we can simply click on athlete and start exploring what's going on with each of these in Neo4j Browser. But remember, again, Neo4j Browser is not a full-fledged visualization tool. It's more meant for querying, administration of database, setting security controls, and so on. But just a quick overview of what it can do. Click on relationship types. You will see some cool connected things. But really, right at the top here, you can see, right, athlete 1 and athlete 2, and they are part of the same team in different in same team, part of, or both of those are part of multiple teams together. So these two have been um, playing together in these sports. So at the very surface of it, you can start visualizing some cool patterns already, but that's not what we are here for today. Cool. Let's just quickly make sure that Sandbox is done as well. I knew it. Okay, so if you are getting this transaction timeout error, do not worry. You can simply go in here again and just remove this part of it, okay? Because once you have created indexes and constraints, you don't need to run this part again. It will error out. So just remove this and let's try rerunning. It's a 40 MB file. There might be some internet issues trying to pull the file. Let's make sure it's going through this time. Oh, by the way, this repo is it's built by Lou, who I mentioned before. She does not work for Neo4j anymore, but she has developed fantastic artifacts for Neo4j, this being one of them. And she used to do this session. She honestly did a very wonderful job when she did it the last time. But oh, cool! I can see 18,000 nodes added. So just making sure that data is getting loaded in Sandbox as well. Perfect. Let's go back to the slides. Setting up the perspective. Cool. Now you will ask, hey, what is a perspective? Why are you saying this? Let's set up perspective. Why? Perspective, like I mentioned, is a view of data. Alex, I know I want to go into the presentation mode, but it just makes it very easier to navigate from here. So I'll stay right here. If you see something sensitive, ignore. Kidding. So perspective is a view of the data. It lets you control what from your schema you can visualize, Or if you are an administrator, it lets you control what all from the schema you can allow someone else to visualize. And we will look at that, and we will look at all how to do that. But when we will open Bloom, just so we don't get overwhelmed as to what's going on, that's why we are showing this really important slide as to how the canvas will look like. Um, oh, don't worry, we will open Bloom and do all this again. So there is going to be this background, plain background, which we call scene or canvas. You can call it anything you want. This Bloom scene, which is going to be the source of visualization. So all nodes and relationships and all beautiful visualizations are going to be rendered on this scene here. Like you see here, the pink nodes. There's a legend panel on the right hand side. So whatever is being visualized, you can see what is being visualized in this legend panel, color of the nodes, and so on, and how many nodes are being visualized, and relationships as well. So this is the legend panel. There is a hierarchical layout toggle. So just a quick note there that by default, Bloom and most of the visualization tools out there, they will by default render the data in a forced directed layout. What that means is that the most connected nodes stay at the center, and then the least connected nodes sort of start to edge out towards the end of the scene or towards the leaf part of it. But in Bloom, you can toggle hierarchic. So if you have deeper hierarchies like employee manages employee, and so on, if you have a hierarchical tree structure, you can switch to a hierarchical layout to visualize how that tree looks like or how that hierarchy looks like. There are going to be some scene controls. So this is like a mini map. If anyone has played Age of Empires or Defense of the Ancients or all those RPG games, then there is a mini map at the bottom of every game, right? Where you can sort of see the whole picture. It's the same here. You can navigate across the mini map if there's too much to visualize. Zoom in, zoom out. You can go to presentation mode, which sort of removes all the clutter and just shows the visualization part of it. There's a card list, which we will see in a while, some basic about settings and help drawers. And then there's a sidebar, which of course we will look at, but that's going to show all the information to us. There's a filtering option. So once you have a bunch of data on scene, you can really filter as to what you want to see, what you want to pop out, and so on. And the perspective drawer, which we will begin with. And the most important part is the search bar, which really enables you to do that near natural language search without without writing any cipher query. Cool, let's go. So let's open Bloom. Now going to the Neo4j Aura console again here. Okay, Neo4j Aura. Okay, actually, before we do that, let's quickly see if we have any important questions. Just so I don't confuse you, I'm going to stop. Okay, I don't see any questions. Going back. Cool. Going back to Aura. Click on the Open with drop down and click on Neo4j Bloom beta version. Now it says beta because it's in the beta stage on Aura, but it doesn't really miss out on a whole lot of features except perspective collaboration. But it's fine. The username is always Neo4j unless you change it. The password is what you have set it. The new shorter password, or if not, the saved password, and hit connect. Bloom is going to show this wonderful connect. Same thing for Sandbox, open with and open with Bloom. It shows here, make sure you copy the password. If you have pop-up blocked, then you can click on this link to force the link to open. Again, password is Neo4j. Sorry, username is Neo4j. Password is the one that's saved here. paste that and hit connect. Let's make sure this Bloom is open. Awesome, cool. Um, let's also make sure this Bloom is open. Not yet. Okay, no worries. Now, as you saw here, this is the first thing that you see. This is the first thing that comes up when Bloom opens, right? You see here untitled perspective. Now this was a default. This is called a default perspective. So by default, uh, Bloom gives you a perspective to start playing the dataset with. So you don't have to create anything. But for the purpose of this exercise, we are actually going to create or really auto-generate a perspective. To get there, click on this settings or two bars called perspective. Now this is going to take you to this sidebar that we mentioned, that we talked about, shows information about categories or node labels. So we have athlete, game, city, country, team, event, and medal, and colors for all those. Don't worry, the colors are changeable. And relationships between those things. Ignore this search phrases for now. We will go into that in a later part. Um, but to go to the perspective drawer or to see all your perspectives, click on this 9 dots. Again, let me show that again. Click on these 9 dots or really anywhere here to go to the perspective gallery. So if you have a big chunk of data, you want to lock down access to some parts of the graph, you can have a lot of perspectives, which will be here. Or if you have an existing perspective, you can even import it. But for the purpose of this exercise, we are going to create one. Let's go ahead and actually delete the default one just for the sake of it. And then we are going to click on create perspective. Two options, generate and blank. Blank perspective is not recommended if you have a lot of labels and stuff. The best way to get started is, again, generate perspective. Bloom is going to intelligently read what's in the data and generate a perspective for us. Same thing with Sandbox, generate perspective. Oh, Aura is not letting me do that. Probably got angry because I deleted the perspective it gave me. Here you see that in the Sandbox version of it, our games athlete perspective 1. So it auto-generated a perspective fairly quickly. Not sure what's wrong with Aura Bloom here. Give it a couple of minutes, seconds. But we just looked at this, right? Here is where you define the perspective and so on. Okay, let's actually reopen Bloom. Oop, my database is offline. Huh. Oh, running again. Magic. Okay. That's probably the reason why the perspective was not getting generated, because the database was offline. I'm curious if there is an outage in GCP or something. Okay, let's do this exercise again. Delete the original one, generate a new one. Hey, there we go, creating perspective. So now you see that we have this perspective created, 36,000 nodes, 102,000 relationships, 7 labels, and 6 relationship types. And I will click on use perspective. Once here, you remember the 9 dots is where you go for the perspective gallery. This is where you will define the perspective as to what is in the database and what not. The right pane, like I mentioned, is the legends pane. So athlete is yellow, city, orange, and so on. Let's just quickly go with this. This is the mini map that we were talking about, the filter that we were talking about. So everything that we just saw in the slide part of it is right here. Now, a couple of things I like to do is the node query limit. So this is a toggle. You can go all the way to 10,000, but the key part here, or something to ask yourself, is that what am I going to do with 10,000 nodes? If you have a 10,000 nodes on your screen, of course it will look like a hairball mess, right? It's going to look messy. So I like to limit it to 1,000, just so I can see, I can visualize it in a better way. And then you can auto select results, case sensitive search, turn it on. Helps when you're doing some case sensitive stuff, but that requires another feature. But just turn it on if you want to, not required. um, and let's go back here. Cool. All right, now the next part of it is a little bit more, going a little bit more into it, right? What can we do with this? But before that, hold on, before that, let's actually create our own perspective. So what we did was we generated a perspective, so Bloom knows. Let's create a blank one. Now when you do a blank perspective, there is going to be nothing here. I mean nothing, no nodes, right? Now you can add a category one by one. Let's say we want to add let's say we want to just obfuscate all the athlete information. So what I can do is I can add uh, games. See, games is added. I can add event. I can add country, and I can add city. So you see that if when I add these four, I am obfuscating, or I am hiding athlete, medal, and team. So whoever uses this perspective is not going to be able to visualize athlete, medal, and team, because I did not allow them to, right? And that's where this creating perspective yourself, or defining perspective yourself, comes into picture. Um, but we are not going to use this. We are going to use the original one. Now you might ask, how do I lock down access to, or how do I change the predefined perspective, right? It's pretty simple. What you can do is just hit on athlete and click delete category. It's going to make it go away. Um, just like that. Pretty cool stuff. Um, let's actually look at something. Uh, yeah, like it's all what we mentioned. I don't want to run through the slides again and again, but it will show all the existing perspectives, and it really is going to enable us to visualize between these set of nodes and labels. Now Bloom uses indexes to search for what we type here in the search bar that we will look at right now. But if you don't have indexes, so if you remember, we created indexes on athlete ID, game name, city name, country name, and so on, right? We created index on athlete name, country name, and so on, right? So when you have those indexes, Bloom is going to use those indexes to search. Let's do that. Um, let's actually start. So here you see, once you click on the search bar, Bloom suggests you what's in the schema. So we have a bunch of labels, a bunch of relationships, right? And you can start by exploring these one by one. So click on athlete. Ooh, beautiful. So 1,000 nodes found, and you can zoom in to see names of these athletes right here. Good stuff, right? Quickly go back to see everything. So we have these 1,000 nodes beautifully popping out. Now, in order to clear scene, you can do right click and click clear scene. You can also, let's visualize country. See, country is popping up. Pretty cool, right? Dismiss or clear scene. Now, like I mentioned, you can actually do a near natural language search in Bloom without having to do a lot of work. So let's search for a random athlete. Let's do David Dave Anderson. Cool. There we go. We can quickly pick Dave Anderson just by searching Dave Anderson. Bloom knows Dave Anderson is an athlete because we have an index. You can easily pop up Dave Anderson right here. Um, all right, it's your turn. Or actually, if you have followed with me so far, it's good. We have already done all this. Let's do some simple searches in Bloom. Actually, let's take a 5 minute break. And in those 5 minutes, you feel free to grab coffee, do a bio break, or create your own perspective and search for some stuff. See you in 5. Hey everyone, time to start back up.
Yeah, we actually have a question from chat,
Okay.
so maybe we want to we'll take that on.
Yeah, sure.
Um, how can I search for a particular athlete, e.g., with name in the Bloom scene? I think that's kind of where we stopped. And
Yes.
you showed it a little bit, but maybe you can show it again or show it in more detail. That'd be good.
Sure. Yeah. So let me clear the scene again. Thanks for the question. So if you know who you want to look for, you can directly search. So again, let's search for another David. I just typed David, and Bloom knows that okay, David is an athlete because of the index, right? It knows that okay, David is an athlete. David is not a country. Can go for David Harlock, let's say, and then hit enter. That's going to bring up David A. Harlock. There is one more way to do this, and I will show that in a minute. But yeah, great question. I hope this clears it out. Uh, oh, by the way, you can really search for United States. Oh, okay, no. Let's search for Russia, and pops up Russia. It knows, but our team also has some Russia in it, so it is also going to recommend me that. But Bloom knows Russia is also one of the country nodes, so you can look up Russia here. Not sure why there are three of these though. Oh, just going to dismiss clear scene. Cool. All right, let's move on. So simple searches in Bloom, just like the one we did, you can either start by typing directly a name or something if you know what you're looking for. If you don't, you can look for a node with a specific property name, or you can directly type a category, right? And let's do that. There's an exercise coming up for you all. Is there expansion? Okay, cool. So let's go here. Okay, so some ways to really see what's going on is either we can do athlete directly, which is going to show us all these thousand or so nodes because we limited it to that. If not, since this is a lot of information to consume, right? We can directly search for the athlete name like we did. Or another way, and this is the way to search for that specific, is that you can, and this is where the near natural language search comes in. So I want to look for an athlete named something, right? Or I want to look for, let's say, athlete name. So here, if you see, the name colon pops up. That's how I know that I'm searching for the athlete name property now. Now there are a bunch of those, so I'm not going to search for the athlete name, but instead let's do country. Country, I hit tab, name, country name, and then let's do Russia. And when I do that, it's going to bring up these Russia nodes because I searched for country name Russia. So this way you can search using properties. Now let's clear scene and let's go back to that Dave Anderson. Now the reason I'm going back to Dave Anderson is that I want to show you something. If you hover over Dave Anderson, you see this little tooltip come up where you can see the name property. But if you go to the perspective drawer here and click on athlete, okay, let's actually bring him here. Click on athlete, you can see that you can choose what caption you want to show. So you can show the athlete's name and sex, or the page rank score, which don't worry about it right now. We'll talk about that later. Or we can choose the ID and so on. So really cool, right? Another thing is that if you double click on Dave Anderson, it's going to show this card list, which shows you all the information about Dave Anderson. And then you can explore relationships connected to Dave Anderson. So What this is, that it's showing you the neighbors. It's showing you what Dave Anderson is connected to. And then the neighbors card, like I said. So to expand this, you can go to neighbors and double click on this one. Oh, I think this one. Yeah, awesome. So if you see here, when we double clicked on Dave Anderson's relationships, one of the relationships, it actually expanded that relationship to uh, Canada Alpine Skiing Men's Downhill 2002, right? Now we can again expand. There are a bunch of these, right? David, so on. We can actually expand the first one again by just double clicking. You can see that this team participated in the Salt Lake City 2002 games. Again, inspect this, and there are going to be a bunch of relationships since multiple people can be participating in that. Um, but we can expand this relationship here, that the games were actually held in the city of Salt Lake City. So now we have constructed this nice little pattern here. We started with Dave Anderson, and we reached all the way to Salt Lake City, correct? Uh, Now, this is how you inspect a card and sort of go from there. Now, remember, I told you you can exclude and include things. So if you click on exclude sex, let's say I don't want people to see the sexes of these athletes. So I will click on exclude, and then it's going to just disappear from here. So no one will be able to see. So that's one of the ways of locking down or securing your data from the perspective point of view. Now, another way of expanding what's connected to Dave Anderson is to directly explore Dave Anderson, right? But it gets hoppy a lot because you expand one, you expand two, and so on, right? So let's actually get rid of everything but Dave Anderson. To do that, click on Dave Anderson, right click and say dismiss other nodes. So it's going to dismiss everything but Dave Anderson. Now let's explore this guy again. There's an expand option which shows what all you can expand. So it looks like there's only one thing you can expand. So I'm going to click on all. It's going to bring up the Canada men's thing. And now if I hover on expand, you see I have a bunch of options to expand on, right? I can do all, or I can select what to expand on. Let's say I want to expand on which part of the team participated in. Since that was the pattern we were looking at, we can do this. And then let's also expand on here. So you see that there were 1,503 teams that participated in this Salt Lake City 2002 games. So we can choose to expand that. It will show 1,500 nodes. Not very useful for us. We want to construct the original pattern. So I'm going to expand on held in. And you see that this pattern we managed to construct using the expand feature. Now, real quick, you can do hierarchical view. It's going to go top to bottom since this is a hierarchy. You can rotate the hierarchy, and this I really like for certain use cases, right? You can see your tree from top to bottom, left to right, and anyhow. Let's go back to FDR, and we have this right here. Cool. All right. So where was I? Oh, okay. Cool. So let's take 5 minutes, and this is an exercise, sort of DIY exercise for you. Try looking up Maxime Dufour Lapointe, or actually, you know what? I will do it with you. Let's do this together. So we will look up Maxime Dufour Lapointe, and then we will explore Maxime Dufour Lapointe. So let's clear this scene here. And now two ways to do that. We can either do athlete name. So we can do athlete name and Maxime But the thing here is that you have to be very careful in this one because you need to know what you're searching for because the property name is set, right? And it is case sensitive. So instead, what we are going to do is hit this cross to clear, and we are going to do maxim default point directly. So Bloom suggests me what to do. Click and enter. Now you see, we see maxim default point. Here, let's do the card view relationships. So this person is actually a part of Canada Freestyle Skiing Women's Moguls 2014. Pretty cool. Uh, let's keep expanding this one through one of the ways. Ooh, I see there's a bunch of thing going on here. So what I'm going to do is, instead of doing this one by one, I'm going to do it old school. So let's click on expand. There is an advanced expansion option where you can select multiple relationship types to expand on. So you can select which one you want to expand and set a limit as well. Let's actually expand all and see what comes up. Ooh, okay. So here's something very interesting, right? Um, let's switch to hierarchical. Oh, that's not going to help. So here's something interesting. We started with Maxime Dufour. We know that she is a part, or he or she is a part of Canada Freestyle Skiing Women's Moguls. But now looks like there's a couple of other Dufour Lapointe family. So this looks like a family. This looks like a family event, right? Three of the Dufour Lapointes participating in this event. One more person, Audrey Robichaud, participating in the same event. Um, and they participated for Canada, and looks like they won silver medal. This event took place in Sochi, and you can really see the game name and so on. So with one click, we have explored one hop neighborhood for Maxime Dufour Lapointe, right? Pretty powerful because if these connections did not exist in your graph, you would not know how to explore, right? Let's go ahead. Oh, actually, if you can see here, we are correlating. So pink one is the games, green one is the middle, and so on. Let's do one thing. This is actually in the later part of the course, but I want to do this right now. Let's click on athlete, and you can see here you have option to change colors. Let's keep it yellow, make it brighter yellow. Can change size as well. An icon. Let's give these things an icon. So let's start by typing athlete. Ooh, something comes up. Let's see if there is something closer to Winter Olympics. I think this is skiing, right? Okay, cool. So we are going to denote athlete by this. City, we can give type city and see what it is nice. Yeah, everything is nice. This one is cool. Setting icon for city. Let's go for country. And this was actually in the later part of the course, but I'm just going to do that right now so we can have those beautiful visualizations. Event. Okay, this is, let's give it event. Game is going to be a difficult one, but let's do maybe this. Okay, medal. Perfect. And then a team. So yeah, bright ideas. Cool. Now you can see this is a prettier visualization when you add these icons, because when you go back, you can still see the icons to make out what's what, right? You see games, medals, and so on. So we already have a very pretty visualization. All right, great job, everyone. Let's see what we have in store for next. Um, yeah, it's just some basic stuff that I already explained. We don't need to go over that again. So patterns. Now, just like we explored everything one by one, we can build a pattern in Bloom. Because of the intelligent natural language search that Bloom does, when you start querying one part, like Maxime Dufour Lapointe, you can actually say it out loud in English, like, okay, Maxime Dufour Lapointe is a part of team that competed in an event. Now, of course, you cannot type the whole sentence, but if you pick out those verbs and nouns, which are basically nodes and relationships, you can see Maxime Dufour Lapointe, part of team, competed in event, Maxime Dufour Lapointe, part of team, event, and so on. You don't have to put all those relationships. Bloom will automatically fill out those gaps for you. Let's see how that works. I am going to search for Maxime Dufour Lapointe, and it suggests me. If you look here, it starts suggesting me either the single node or there is a team connected to Maxime, or Maxime is a part of team, right? Let's go ahead and try the first one. So Maxime Lefort Dupoint, and I can start part of um, part of team, and the team competed in. Oh, got something wrong. Part of team, and it starts suggesting me these what's coming next, right? So competed in. Oh, come on. Yeah, okay. Part of team and competed in an event. So here you see Bloom actually filled out those gaps for you. We just started typing, and Bloom was intelligently suggesting us what we can do next. And when I do this, it's going to automatically pop up that visualization that, hey, Maxime is a part of this team which competed in this event, right? It's pretty fast, pretty intuitive. Let's go ahead and clear the scene, and let's do the same thing in a different way. So again, we start with our beloved Maxime. Now, the first part we did was to start with relationship, but we can actually do directly. So Maxime Lefort Dupont, Duport Lapointe, belongs to a team, and Bloom is now going to suggest what all is connected to that team. So you can either do again an athlete, country, event. We want to see event. So Bloom has built out this pattern based on the schema on its own, and we get the same visualization. Maxime, part of this game, part of this team, competed in this event. Now this is very powerful because you don't need to know Cypher. You don't need to write code to get these visualizations right.
There is a, a question from chat that might be interesting to put in here now. Is one important information from Yingding is I forgot to clear scene and things get messy, so always clear scene before you start a new search. I guess that's a good that's a good learning.
Yeah. Yeah, that's a very good learning. Oh yeah. And my bad for not mentioning that. Yeah, if you keep doing those visualizations on and on and on, it can get really messy really fast, and it's just going to slow everything down. So if you want a fresh start, always clear scene. Once you start noticing that things are getting laggy, make sure you're not over visualizing, and just visualize the part that you want to get some information out of, right? um, was that the question, Alex? Sorry to cut you off.
No, the question. Yeah, I just would. This is like I saw this and I thought this is good to repeat. And then Victor has a question. He is using desktop, so different setup, but he says his auto search is not working. Is there a setting he's missing, or is there something you could? I mean, it's always hard to diagnose from afar, but should that work, or is there maybe a difference?
Let's see. So if your data is loaded in desktop, so if you already loaded the data using Neo4j, and I think you needed to install APOC, but maybe it comes pre-built. So if you have already loaded data, just make sure that you are in the right perspective. So again, generate perspective, make sure you are in the same perspective. um, and if you have all these indexes already present in the data, it should automatically do that. um, I Yeah, it's really hard to diagnose without
Yeah,
looking at it,
but
but
yeah,
yeah, just make sure the indexes are there. Maybe try running this part again, and if it errors out, says already exists, then you can know it exists. But just make sure that you are in the right perspective and you see all these categories and relationships um, in your perspective.
cool.
Cool.
And
Thanks.
while we're at the search bar,
Uh-huh.
thanks for that question. Um, eh, Roy wants to know if we can use operators such as and
Wow,
in
that's
the
a
in the.
fantastic question. Unfortunately, not yet. Um, but let's see. My friend and colleague Dan Flavin, he actually wrote a very nice. Oops, that's not him. He actually wrote a very nice blog post on how to create conditional queries in Bloom. Uh, he's a funny guy, just like me. Um, so he has actually written this blog post on how you can add conditional operators in Bloom. I am going to paste this in chat. It's a very nice blog post. Um, you can use this blog post to construct those conditional statements, but by default in Bloom, there is no feature to do conditional querying yet. Thanks for the question. That was a good question. All right, let's move on. So there's an exercise for us. Let's find this answer. How would you find the answer to what Olympic Games was Elena Duboc a part of? So let's start with Yelena. Yelena Duboc. And we have a couple of options here. We can either do Yelena Duboc and explore her manually, like this. So we can see she was a part of three teams, forget the question, or Olympic Games. So we need to expand all the way out. So in order to select just the team nodes here, you can click on the team at the right hand side here. So it will select just the team ones and then expand and then part of. Nope, I expanded the wrong thing. But that brings me to a feature. All right. So like you noticed, I miss expanded. So you can actually undo the action. So if you click on undo, it's going to go back to the way it was. Again, let's go to the team. Let me look at the data model here real quick. So we have the athlete who is a part of team, and look at games or event, right? We want to look at games. So we want athlete part of team game. So let's go here, athlete part of team. What's the relationship type? So you can see how I'm using this schema.visualization to as a reference. Participated in. So I want to expand participated in. Awesome. Now this is a very nice visualization. Here you can see that we have what we did was we manually expanded the schema because we knew of it. So Yelena Duboc part is a part of a couple of teams that participated in the Salt Lake City one, and she was a part of another team that participated in the 1998 Nagano. Another way of doing this is through the schemas, through the search bar directly is, let's go with Yelena Duboc. Let's go look for team, and then let's look for the games directly. So when we do this, we are going to get the same result, but much faster without having to explore anything, without having to know anything, right? Um, just through simple schema search, just through simple search bar. So or you can even go the other way around. So games, um, give me games, give me team, and then Yelena Jubok. So this was one of the interesting findings from one of the past webinars, that you can also go the other way. Gives the same visualization, right? The logical way is, of course, to go straight, but hey, multiple ways to solve a problem, right? Clear scene. Let's move on. So this pattern building feature of the search bar, we can do some interesting things. We can find those hierarchies, or we can do long chains. We can do those deeper path expansions. We can search between two anchor points, two fixed nodes, or we can search for cardinalities, like, hey, give me all the people connected to this particular game, or give me all the people who have won gold medal through something, right? So let's look at something like that. Something just as an example. So Elizabeth is a part of team that participated in some game, and Eric Arthur is also part of the same team. So we can expand these cardinalities, or we can expand these paths. So let's do that real quick. So Elizabeth, forgot the name. Beth. Wait, what was that? Elizabeth Lee Beth. Okay. This was the one. Then we want to look for part of team. So we will not look at, you can choose to type part of, or you can just directly go to the schema, suggested schema, who is a part of team, who participated in games. So notice that the verb part of it is relationships, and Bloom is abstracting it away because it knows what structure the data holds. So participated in games, and then we want to look for someone else who participated in same games. So now we'll go backwards from team, and we want to look for Eric Arthur Hayden. So I'm going to type Eric Arthur Hayden. Now, if this person did not have any connection, and let's type Alexander. Now Alexander does not exist in this database, right? He does not exist in the Winter Olympics dataset. So that's why Bloom did not suggest, or Bloom did not pop up any results. Or if you type Soham, I'm not an Olympic athlete, so I'm not in the dataset. But if you type Eric Arthur Hayden, it suggests what Erics we have, but we want Eric Arthur Hayden. And if we query this pattern, that's going to show us a very cool visualization. So we have Eric, we have Elizabeth, who were part of some common games, right? So they were part of a bunch of games at Lake Placid in 1980, and a bunch of other games in Innsbruck. So notice how we constructed this pattern. Notice how we constructed this search without having to type a cipher query, building a pattern from the search bar itself using Bloom's schema search capabilities. Very nice visualization. And the icons really make it better, right? I really think so. Let's do next one. So like I said, we can do cardinalities. So games, city, games. That means if you can guess it, what we are looking for is tell me if a city hosted more than one game. So pretty simple stuff. Games. It suggested me because city and team is the only thing that's connected to games, and then game. So city and looking for games in the same city. So quickly we can see multiple games happened in the same city. So Innsbruck, Lake Placid, and San Moritz. Clear scene. We can travel across several hops using the same features. So games, team, athlete, team, game. So at the center of it is athlete. The question becomes, hey, I have an athlete. tell me if he was part of multiple teams in multiple games. So here you are expanding the neighborhood quite a bit. Let's try this out. It's a pretty interesting visualization. So games was a team, and then athlete. So this is the one way to look at it. So we have games. Athlete belongs to a team who attended games. And now we are going to go reverse, going to go team and games again. So this is the pattern we constructed without even knowing how you write cipher query, right? It's all happening very fast without knowing anything. Restricted to 1,000 nodes because it can get messy, and it did. Um, let's see what we have here. Let Bloom settle down for a bit since it's a very tight visualization here. But at the center of it here, you can see there's a games, right? There is games node. I hope I expanded correctly. Yeah, I did. Okay. So there is a games node. Let's look at it. What is this games node? Oh, Calgary, Lake Placid, Innsbruck. So those nodes with the highest number of connections and densities are here. But what we can look for is that we can look for commonalities. We can look for all the athletes who are sharing multiple games. So real quick, let's go here. Actually, let's go to this place. Let's look for an athlete who has drawing out all the countries here. So now why is this powerful? Because now we are shifting. If you see, the nodes started shifting depending on who they are connected to, right? Let's look for an athlete tied to multiple. We can inspect, of course. So double click, inspect relationships, inspect neighbors. Not this guy. Okay, maybe this one right here. So you can start seeing all these between athletes and between games, right? So although a messy visualization, but still deriving some information out of it. Quickly clear scene. Now properties. Now we saw this when we did, I think when we did the first person, David Anderson. But let's check how to do that again. So I want to see all the games that happened in the year 1972. Now we can write a cipher query saying match games where games.year equal to 1972 and then return the node. But why? We can directly do that, right? So we can do games year, and this brings up the property console 1972, and hit tab and hit enter. I can see Sapporo 1972. Now we can easily build on this. So show me the city that this game took place in. Quickly look at Sapporo, held in Sapporo, right? Um, or we can go back and see, show me all the teams that participated in and the countries that participated in. Now this might be a heavy visualization, but we have all we have expanded this neighborhood for a game that happened in 1972. So the query here we are building out is that, hey, okay, show me all the games that happened in 1972, and show me all the teams that participated in it, and what countries do they belong to. Now I want to show a feature here real quick. Let's dismiss everything but the country nodes. In order to do that, you can either manually select or do control A or something like that. But a more quicker way, or a more intelligent way of doing that is through the legend pane. So let's click on the country nodes. You can see the country nodes are being highlighted. And now I am going to, after selecting country nodes, I'm going to click on one of the country nodes and say dismiss other nodes. Boom. Now, very nicely, we have managed to get rid of the messy visualization, leaving just the countries behind. Just another way of doing clearing those things out. Let's clear this and quick. Cool. Time to answer some questions. How many gold medals has Claudia Pechstein won? Now, again, everyone, you can do these exercises yourself again to just as a practice. But the reason I'm doing this with you is because I'm having fun, and uh, it's quicker that way. We have 18 minutes left. We can go 5 minutes over, but um, I'm having really fun doing this together. How many gold medals has Claudia Pechstein won? Let's take a look at that. So first, let's inspect the model. In order to get to the medal part, we need to go through athlete, team, and medal. So a small modeling problem here is that in order to get to the medal, we cannot directly go from athlete to medal. We could have loaded the data that way, but since we have to go through athlete, team, and medal, let's explore this pattern, athlete, team, and medal. Now, remember, we are looking for Claudia Pechstein. So instead of exploring all the athletes, we can start with Claudia Pechstein, belongs to some team, and I want to see all the medals she has won. So pretty simple pattern, constructed, hit enter, and that's going to bring up Claudia Pechstein. So here, bronze. Looks like she has won 3 broader medals, but since remember there is this modeling part of it that we have, she has actually won 11 medals. How so? Because even though she has won 3 different kinds of medals, we can see here that she has won gold in some, bronze in some, and then silver in some other event. That means she has won total 11 medals. 3 of bronze, 7 of silver, and then some more of gold. Now, I want to show something really cool here. I was refraining from doing this. Actually, let's complete this exercise and then go for it. Going to clear scene since we have answered the first question. The next one is how many teams has Lamine Guy been in? Pretty simple. So this model we want to look for Lamine Guy and how many teams he has been in. So we can start with Mine and expand the teams. Single hop visualization. Pretty quickly we can see Lamine has been a part of 9 teams. Now the reason I'm zooming out to this extent is because I want to show these how helpful these icons are when you look at the legend pane. Okay, don't need to go deeper and deeper if you don't want to. Second question answered. So can we find some athletes that have represented more than one country? So that means we want to find athlete who have represented more than one country. So we have to go through the team again. The pattern is going to be something like athlete. Oops, that's going to be messy. Quickly clear it out. Athlete who is a team, part of team who belongs to a country, and we want to represented more than one country. So we want to look for athletes, 2 athletes who belong to some team, but they belong in the same country. Now expanding, this is also a slightly bigger visualization, which is why Bloom is taking a little bit of time. Remember, smaller instance. Just hope it comes back. Oops, spinning wheel of death. Let's try this in the sandbox. So same thing again, we want to look for athlete, part of a team, part of a country, and athlete again. Let's see if this one works. Oop, this one is going to time out most probably.
While we see if it works, a quick question from chat.
Mhm.
These almost autocomplete or these easy Bloom type serve phrases, can you in some way export them into Cypher queries so that you I know the other way around works, but can you also do this way around? Do you know?
That's a good question. So, not in Aura. In desktop, you can potentially look at log files and see what query Bloom is running and do it that way. But there's no very easy way to do that. That's a very good question, though, and
Yeah.
actually, it's a good feature request too. I'm going to just write that down um, to export these queries.
Good.
Yeah, fantastic. Thank you.
Yeah. Thanks for that question then. Yeah. Cool.
So something came up, but it's not helpful. Actually, it is helpful. Okay, so we are looking for athletes who have represented more than one country. Let's look for this particular more than. Okay, no, multiple athletes. Wait, what was the question? I forgot. Who have represented more than one country? Oops, my bad. So that was a wrong search, guys. Um, that was a wrong search. We want to know athletes who have represented more than one country. So we want to go with um, athletes belong to a team, belong to a country. Um, Actually, it was correct. No. Okay. So we want to look for athletes, team, and country. And then we want to look for athletes, team, and country. Okay, I expect this is not going to come back. Okay, and then team and again country. So again, it's a slightly bigger visualization, which is why it takes a while to come back. And we are kind of short on time, so see if this returns real quick. Or we can look for here. What different ways are Olivier Genot and Patrice Servel connected? So we want to think about how are two athletes connected. So they can be either part of the same team, or they can be participating in the same game, or competing in the same event, or representing the same country, and so on. I'm going to kill this search phrase because it's not returning. Um, it's fine. No worries. We can move on. So we want to look for Olivier Genot and Patrice Servel. So looking at the data model, we want to look if they are actually if they represented the same country. Let's first take a stab at that. So Olivier Genot, uh, team and country, and then team and then Patrice uh, Patrice Servel. Patrice Servel. So let's see. Okay, so now because Bloom already recommended this us, that means they actually do belong to the same country. Hey, nice. So we can see Olivier Genot and Patrice Servel participated in a bunch of, or were part of bunch of teams, and they actually represent the same country called Monaco. Were they part of any, or do they share the same team? Were they ever part of the same team? Doesn't look like it. So they were never part of the same team, but they actually shared the same country. Let's see if they actually participated in the same games. So part of a team that participated in game. Actually, let's try event or games. Let's try games. Oh, sorry for that. And then the other way around is Patrice Sorvel. Oh, cool. So Big Bloom is recommending this pattern. That means it exists. And oh, nice. Twice. Okay. So these two were actually, they participated in Sochi 2014, and the other one is Torino 2006. So they represent the same country, and they participated in two different games. Let's also find out if they did anything else together. Let's see if they have any event that they share. Patrice, Survey. Oh my, okay. These two are really good, connected people. All right. Patrice Servel. It's not letting me search. Interesting. What we can actually do is we can expand these two manually. Oh, no. Okay. Let's expand on teams and see events. So participated in. My bad. I am going to hit undo again. Let's take a look at the, oh, competed in. Okay. Okay. So I want to see if these all these teams that they belong to, did they compete in the same event? Okay. I don't think so. Okay, so even though they represented the same country and they were in the same, they were in these, do you say, they were in these two events together, but they don't have any common event or game together. So just tells us that they represented the same country. That's how they are linked. Just a bunch of different ways to find out these connections, right? Now, as we have seen here, right, we can expand nodes, we can dismiss nodes. Another one here is that, let's look for, we should have kept that visualization, but okay, let's look for Patrice Servel again. And let's just have something on the canvas to show country. Team. Who was the other person there? Keep forgetting. Olivier Genoa. So Olivier Genoa. Okay, cool. So we'll have this open here. Another way of actually, yeah. So instead of dismissing one by one, you can also do something like select two nodes using lasso. So just hold down the button and select, hold down your left click and select these two to either dismiss or expand and so on. Now, one interesting thing here is that we can do shortest path. So shortest path between two nodes. Now there is no metric here, but we can just do shortest path. So let's look for shortest path between Patrice and Olivier. I am going to select these two and dismiss all others. And now I'm going to select these two again. Now shortest path is only between two nodes. So I'm going to find path and then shortest path. So this is going to give me one of the shortest path, not all of them, but can quickly see how these two are connected through the same team, right? There are multiple connections, but since shortest path shows one of the paths, we can see that they are actually connected through the same team. Okay, oops, go back here. and clear this thing out. I'm going to skip this. It actually is not very good. Okay, now let's look at a very powerful feature. I know we are short on time, but if I think we can go 6 minutes over if needed. So there is this technology. There is this thing called search phrases, right? And search phrases is something really cool. Uh, what we can do is search phrases actually allows you to define a cipher query and then parameterize part of it, so you can use those parameters to fill in what you want to search for. So let's do that. Let's define a search phrase. Don't worry, we already have created the search phrase for you. Just copy this one, head to Bloom, head to the perspective draw, to the right to the pane, and there is this thing called search phrases. Now it's going to let you, if you click on add, you can define the search phrase, the description, and the cipher query. So let's actually first put in find an athlete. So I want to find an athlete based on the first name, last name, or middle name, or whatnot, right? So that's going to be my search phrase. And $1, $2 is going to be just the names, the parameterized names. Let's give this some description. We have that built out for you too. So find out person based on first and last name. And then we can put this cipher query where we are actually doing some fuzzy search uh, using, oh, did I quit Bloom by mistake? Oh no, okay. Yeah. Um, fuzzy search based on this. The warning says that this query can be written in a better way. I agree, but this one solves the purpose. So the data type for this is going to be string, as we are going to look for names, and then label key. So we are going to look for label athlete and then name for an athlete, right? And same for the other. So parameter 2 is also going to be a string, and we want to search for athlete names. After doing this, we have actually defined the search query, and let's see what we get. So you see that the search phrase is saved here. Find athlete called $name1, $name2. Let's look for something. Uh, is there anyone that we can search for real quick? Okay, so let's search for Mary Myers, right? My search phrase is going to be like find athlete called. So when I start typing find, Bloom automatically suggests me the search phrase find an athlete called, and it starts suggesting all the names here. But we want to do find the athlete called Mary. Um, what was the name again? Mary Loss. No. Oops. Technical issues. Sorry for that. Let's go ahead and search for someone. Okay, let's search for Mary Littlejohn. Okay. So find athlete called Mary John. Let's do this. So let's do for Mary. Okay, this is definitely a bug. Not letting me search. Third time's the charm. Mary John. So when I type this, it's going to do a fuzzy search, right? It's going to do a fuzzy search and find me Mary Kathleen Littlejohn, because even though I did not specify a full name, I did a fuzzy search with my search phrase, and it contains Mary and Littlejohn, so Mary and John. I can also look for the same node, so let's dismiss this real quick. She had Adams in her name, right? So we can do, this bug is really annoying. So when I hit my delete key to go back, it's not letting me actually delete. find athlete called Mary Adams. So this person does not exist, but we are going to do a fuzzy search and find Mary Kathleen Adams because it has the name Mary and the name Adams in their name. So this is what you can do with a search phrase. You can fine tune your query. You can find or explore some frequently explored patterns in here. You can really test out your search phrases. So the next thing I want to show, and I'm going to go 5 to 10 minutes over, if that's okay. But it's really worth it. So let's look for a simpler subset, medals, right? I can edit data in here. Actually, let's not look for medals. Let's look for a person again. Now, since I remember this name, I am going to look for Patrice Servel. Now, Patrice has a bunch of data in here, right? Bloom allows me to edit this. Now, 8912, I can do 234, and I've edited this property. You can add, you can edit properties here, but remember, you cannot add a new property here. You can just edit the existing properties. Similarly, you can delete a property. You can, let's delete this property here. There we go. But you cannot delete a node. You can only dismiss. Similarly, you can create or duplicate relationships, or create relationships and duplicate nodes. So here, when I right click, there is an option to duplicate Patrice Servel. I'm not going to do that because it will create bad data, but you can definitely, there's an option to do that. In order to create relationships in Bloom, you can select two nodes in order. So let's say I want to create a relationship between Patrice Servel and Silver. I want to say that she has won a medal and directly create. So first I will hold down Command or Control and select Patrice and select Silver. So this tells me the direction of the relationship, and I am going to say create relationship. Now, when you want to create a relationship, you cannot actually create a new type of relationship. You can only create those relationships that already exist. So here you see competed in, held in, participated in. Let's, for the sake of it, let's just create this one. So here you see I have dynamically created this relationship without even looking at it, right? Now let's do something cool. Let's dismiss this. And let's look for all the medal again. I'm going to show you something very amazing. It's mind-blowing feature. In Bloom, you can do something called as rules-based styling. What that means is that you can set a rule on these nodes to style based on their properties. So what I am going to do with these medals is I'm going to click on a medal, and you see here a tab called rules based. I'm going to go here, rule based, and I'm going to click add rule based styling. Now, since we don't have different colors for silver, bronze, and gold, they are all a single label. What I can do is I can actually make it look silver, bronze, and gold depending on the type. So if the type equals gold, then uh, then make the node gold. Did you see what happened there? Isn't that amazing? Based on the value of that property, I actually changed the size of the node, the color of the node. Same thing. Now this is one. I can add another rule, same way for the same type. If the type value equals silver, set it to silver. See that happen? It's very amazing. And let's do the same thing for bronze. If the type value equals bronze, set it to, I'm not sure what color bronze would go. Bronze. How cool is that? Now, since we have these, you can see a little dot on the middle node here. Um, we can very quickly figure out figure out what metal which one is, right? And this was just a test. It's not like this is a real use case here, but you can do this in Bloom. You can have rules based styling. Now, to that, remember I talked about a property called PageRank on athlete nodes. What I can do is I can actually use the property called PageRank. So let's look for athletes. Let's have those 1,000 athletes on the screen. All right. So we have these 1,000 athlete nodes, and I want to find who has the highest page rank. Now, page rank is actually a score that tells you who the most influential athletes are, or who the most influential node in your graph is. What is the most influential node in your graph? PageRank started with Google. Google's co-founders Sergey Brin and Larry Page. Sorry, I'm just throwing extra information here. They developed this PageRank algorithm to rank and sort the links, web links. So the internet is really based on PageRank. Google is based on PageRank, and it shows you the most influential nodes in your graph. So let's click on athlete and add a rule-based styling. So we want to do PageRank. Now, instead of doing a single value, we can do a range. So here we can actually make it. Let's actually do size. You can set the size to 0.25 for the smallest nodes, and size of 4x to the biggest ones, and you can refresh this range and hit apply size. Now you see the size for the nodes changed, right? If you see that, if you see the size for these nodes changed. Now what that means is that the bigger nodes have a higher page rank. Let's take one for example. This node is prominently popping up, Paul Akola. Let's see what Paul Akola is up to. Let's see what he or she is actually doing. So Paul Akola was actually a part of 17 teams. And let's see what these 17 teams have done. Click on expand. So as you can see, it's going to expand all these nodes here. Oh, wow. Okay. So if you notice, what's going on here is that we have Paul Akola here, right here. But Paul Akola was a part of team, and there were a bunch of other athletes that were part of the same team who also have a higher page rank score, because if you see, these nodes are bigger. Now, PageRank, again, some extra knowledge, not necessary to share in this session, but just some extra knowledge. PageRank is a transitive algorithm. That means if I have higher PageRank or let's say if Alex has higher PageRank and I am connected to Alex in some way, I automatically get a higher PageRank because I am connected to someone with a higher PageRank score. So it's a transitive influence of Paul and Didier. So a lot of higher PageRank nodes connected to Paul actually gave him a good PageRank score, and you can do such stuff. But the point here was that you can do rules-based styling fairly quickly in Bloom. Going back to the original scene, not only that, we can also color based on that. So let's ignore size. Let's bring it back to how it was. Going to refresh. Yikes, that's not what I meant to do. Oh, but do you see, it's fun. I had this circular scene, and when I set it to hierarchical, it quickly mended it to square. Cool. All right. It's actually easier to see it that way. Let's try it out. So now what I want to do is, based on the page rank, based on page rank, I change the size. Now I want to do colors. Let's go for colors, refresh range. So range is going to pick min point and max point in your visualization. So if you add more nodes, be sure to refresh this range so that you get more, you get that range cleared out. Now, when I'm going to do apply color, hey, there you go. It shows a nice visualization where the darkest nodes have the highest page rank in this visualization. And I think that is really, really cool. Um, some nodes prominently pop out. Now, a classic real world scenario is that when we talk to banks or when we talk to financial institutions who want to do fraud detection and they want to visualize their set, let's say they have a fraud score and they have this visualization, and you want to make fraudsters pop out. So you want to make people with the highest fraud scores pop out. So you can set a rules based style on that node saying, okay, hey, if the fraud score is above 80, make the node 4x. So then the analysts can see those bigger nodes prominently on the screen, which is really going to make the investigation side and analysis side very, very easy for them. Um, and I think that was it. I did not go through all the slides, but hey, what are slides, right? Um, let's quickly clear the scene, go back to a blank slate, and some more resources. So how, what else can you do, right? Uh, there are a bunch of ways you can really go around. So one of them is, of course, do training certification. Let me see, Graph Academy. So Graph Academy is our online self-paced training. You can go to graphacademy.neo4j.com and we'll share these links. They are in the slide deck. We'll share these links later as well. The other one is documentation. So just go head to documentation, read about whatever you want to read about, and start playing with that. And then we have some community forums. So there is a chat. Basically, we are on Discord, so you can join our community on Discord, and you can join our chat forum on Neo4j community as well. There are a lot of videos on YouTube. You will be surprised. Among all the graph databases that exist in the market, Neo4j by far has groundbreaking number of community participation. So a lot of videos, tutorials, a lot of cool stuff people have done. I remember this one instance. I don't know, Alex, if you remember it. There was this person who presented in Connections. That person had actually done a augmented reality visualization solution on top of Neo4j. You can literally be in the visualization.
Yeah, I
How
remember that. That
Yeah,
was
how
pretty
cool is
cool.
that, right?
Yeah,
So
yeah, yeah.
yeah, exactly. I was looking at that, and me and one of our ex colleagues, Justin Fine, we both were watching that, and we were like, "What? AR? I mean, that's like you can look at nodes, you can move them around." That was just, uh,
It was pretty good. Yeah.
yeah. So
All
you can
right,
look at.
cool. I mean, I think we're a little bit over time, and I think we covered all of it. Thank you very much, Soham, for covering this and for taking us through the journey, getting data in, and also visualizing data in Neo4j Bloom. Thank you for joining, everybody. Thank you for your questions and for your participation. I hope you found this useful, and like I said, we will share the deck as well as the video afterwards, so you can have a look if it was a little bit too fast for you. Otherwise, I hope you had a good time. This is the last episode of this year's actually training series in 2021. So we will continue doing this next year, but until then, hope you stick around. We have another live stream session actually tomorrow, Wednesday afternoon, with Will Lyon. So you can subscribe to that on YouTube. Hope to see you there maybe. Otherwise, have a great day. Thank you for joining, and see you soon.
Hey, Alex, are you closing the session?
I'm closing the
I
session. Anything you wanted to add?
Yeah, I just saw a question by Eric Wang. wants to use APOC in R. So Eric, if you're still on, APOC is something you connect to the database. So if you have APOC library in your database, you can use any language to access the database. Of course, you can use any language that connects to Neo4j to access database and use APOC through that. I just saw the question. Sorry for going over, everyone. I hope it was interesting, and thanks, Alex, for setting it up.
Thank you, Soham, again for doing this. It's really good. Thank you. All right.
Cool.
Take care, everybody. Bye bye.